Hello all. This little clip from Mr. Dwight Doodles is all based on Osmosis here. One of the 5 required practicals. It takes up a huge part of paper 1. Now, let's put it into some context before we begin understanding the required practical. So we know that there are 3 transports. We know that there's diffusion. Oxygen, carbon dioxide, they diffuse, high concentration, low concentration, down a concentration gradient. Active transport, in that masterclass, we looked at that. That's against a gradient. It requires energy from aerobic respiration, thus lots of mitochondria. And the one we're going to look at now is osmosis. And it's probably the easiest one to remember because it's water, agua. And what the required practical requires you to understand, or the knowledge that you need, is the behavior of water, which it comes under the definition of osmosis. So let's say we've had a nice drink of water and we've got 1, 2, 3, 4, 5, 6 water molecules coming through our capillary. And let's say we've got one in there. Our capillary is location A, our cell is location B. Now, as the water moves across, the definition that you're probably aware of is it moves from a high concentration to a low concentration. So what does that exactly mean? Well, high concentration means lots and lots of water. But the more technical way of describing this is a dilute region. And it moves to a concentrated region. Again, what does this mean? Well, if we were to put some salt into our blood vessel, we've still got 6 water to 2 salt. So the ratio favours more water. It's dilute. Think of it as a glass of Ribena, but it doesn't have much Ribena in it. But if we go over here, we've got 1 water molecule. So if we then put 2 salt particles, this one would be a glass of Ribena, hardly any water in it, and it would corrode your teeth. So the definition of osmosis is the movement of water from a more dilute region in A to a more concentrated region in B. It goes down a gradient. What does that mean? Well, there are 6 water particles in location A. Remember, this is a concept. It doesn't actually work like this in real life. And there's 2 in B. And it goes down. So it moves from where there is more to where there is less. More dilute, more concentrated. Down a gradient, and it has to go through a partially permeable membrane. The problem is, if the water moves into the cell will expand. And it will keep expanding until the cell bursts. And that, unfortunately, ladies and gents, is death of the cell, which is not good. So, in order to understand the required practical, you've got to understand that required practical is based upon the behavior of water, which is the definition of osmosis. Water moving from more dilute, more concentrated, down a gradient. A good way to show you this is one of my faves, which is Shreddy's The Honey Edition. If you look at the back on any food product, I'll let the camera focus in, that says salt, and it tells you how much salt is within this product in 40 grams, which is an approved serving, and within 100 grams. How do they do it? How do they know? Is there a special machine they put the shreddies through? No, it's not. They rely on the fact that they know the behavior of water. Now, generally, they talk about a potato. So let's go with a potato. And we want to know how much salt is in the potato. What is the salt concentration within the potato? So what we do know is if we put that potato into pure water is 0% salt. There is no salt. It's just water. So the potato goes in, and we know that water moves from more dilute to more concentrated. Well, we know there's salt within the potato, we just don't know how much. So we pop it in pure water. what's going to happen to the potato? Well, water moves from more concentrated to more dilute through the membrane, partially down a gradient. Potato increases. The potato before was 1 gram. Potato after is 1.5. That's a change of 0.5. 0.5 divided by 1 times 100, and that gives us 50% increase. Okay? All right, still don't know how much is in our potato. We just know when you put it in there, it increases by 50%. So let's go over to this then. What they do next is they take our potato and they place it into a very concentrated salt solution, which basically means they can't dissolve any more salt into the solution. Any more salt that goes in just sits at the bottom. Your potato goes in, but because it's concentrated, remember it moves from more dilute to more concentrated. Potato goes in, 1 gram goes in there. After a time period, when it comes out, it will have shrunk. So let's say it shrunk by 0.5 grams. So 0.5 divided by the initial 1 times by 100, that's also 50%. But that decreased. That one went up. That one decreased. Still don't know how much is in our potato, but we can use these two values to predict what the concentration of salt is within the potato. This is percentage increase, this is percentage decrease. So if we stick 0% there and 100% there, this one being 100% because no more water will dissolve, we know it's not to scale. That's 50% increase. That's 50% decrease. So there's that one and there's that one. If we connect the line at that point there, there's no increase or no decrease. That's the value we're after, because that means water's moving in at the same rate it's moving out, which means that when you put your potato in, it leaves, it enters at the same rate because the salt concentration in is the same as the salt concentration out. That is how they work it out. So let's have a look at what a difficult, challenging question looks like. All right, this here is a 6-mark plan and investigation, a classic osmosis question. It's beautiful because it's got a lot of information on it. It says, a student investigated the effect of concentration of salt solution on a potato, gives the results, plan a method. Well, this comes back to our viaducts here because we're changing something. We can see here, independent variable we're changing. You can see there that's increase, that's decrease. So, number 1, my results, camera shot in here, my results will be valid. Remember, you don't get a mark for that, just tells the examiner you know what you're talking about. Next up, what we have is, what is it I am changing? I am changing. Well, it tells you here, concentration of salt solution. Now, how many do I have? Well, that value there is 1, that value there is 2, that value there is 3, 4, 5, and 6. I am changing, my daughter's come to join me, say hello.
Hello.
I am changing the concentration of salt solution in mole decimeter cube. Big units, don't you worry about that. So I'm just going to put a little arrow there because I'm mindful of time. I've only got 6 minutes to get through this. I then am going to, this is the most important point, I am going to change the concentration of salt solution 6 times. You must list what you're changing from, we call it the range, 0.0, 0.2, 0.4, 0.6, 0.8, and 1 mole dm cubed. And if you don't know what that means, it doesn't matter. You're just using what's in the question. Okay, I will repeat mean average. Let's go down here. Repeat mean average. Remove any anomalies. Dependent variable. Here we go. It's all here. It's the mean change. That means you have to know what the mass was before. Mass before and mass after. And then if you know those two, you can calculate the change in mass. Then you convert that into a percentage change. That is your dependent variable. Okay, units. Well, the units are grams here, and the units are mole decimeter cubed. C, control variables. Control variables. Now let's just have a look. Well, you've got your potato before. We're going to use 1 gram. That's the control. We're going to use the same species of potato. Weirdly, there's 117 different species. We're going to use the same, you could say the same type. And obviously this is science. If you didn't mention temperature, then you'd be bonkers, because obviously the hotter the water, it would increase the kinetic energy of the water, and it would move faster. So that's another control variable. Comes back to T, time. Well, the time means how long is the potato submerged. Anything greater than 30 minutes to 2 hours is sufficient. Pick a time, tell me. And the final one for S, specific to the question, you just run through how you would do it. That's the recipe of how you would do it. Okay, next. Another classic question. You're given a table, and that table is some results of an experiment. Remember, this is a different year. I've got 3 minutes to motor through this question. It asks you to plot them. It says use a suitable scale, plot the data, line of best fit. And it says label the x-axis. So we look, there's your concentration of salt solution. There's 0, 0. What do we got? 2, 3, 4, 5, and 6. So there you've got 0.1, there you've got 0.2, 0.3, and 0.4. You could even do it on smaller intervals, but it doesn't matter. Therefore, let's plot them. 9.8 on 0, 0. That's 9.5 on 0.1. That's 7. That's 0.4. I'm doing this real fast, and that's minus 1.4. Right, there we go. Curve of best fit, line of best fit. That's the bad boy. And obviously, you need to put the unit. The unit is already on there. Now, what was the concentration of salt solution? Was equal to the concentration of solution inside the potato. Remember, where it crosses the line, there is no increase. So your potato in the solution, water moves in, water moves out at the same rate, because the number of salt particles within are exactly the same as on the outside. Finally, here, this is the level 7, 8, 9. Explain, state because why the piece of potato in 0.4 mole decimeter cubed decreased in mass. That's this one here. If you look, it went down by 1.4. Water moved out of the potato. B, that's your state, cause of osmosis. There's mark number 1. You then state that the potato was of a dilute concentration or region, and water moved to a concentrated region outside of the potato. You could even throw in down a concentration gradient and through a partially permeable membrane. That, coupled with the plan question, are the classic, 3 marks, osmosis questions. It might throw you by not using a potato. It might be a carrot. In your question packet, it's about lugworms and what happens with them. So that takes you out of your comfort zone. That then, ladies and gents, is osmosis in a nutshell.